The Fibonacci series is a sequence of numbers where each number is the sum of the two preceding ones. For example, if we start with 1, Fibonacci 1, 1, and Fibonacci 2, 1, then Fibonacci 3 would be 1 plus 1, 2. Fibonacci 4 would be 1 plus 2, 3. Fibonacci 5 would be 2 plus 3, 5. And Fibonacci 6 would be 3 plus 5, 8. Now, assume the prover has a secret X that she does not want to reveal or share with the verifier. However, she claims that she knows X as the second element of a Fibonacci sequence such that the thousandth Fibonacci number is equal to this large number. In this example, we put fib1 and fib2 in input.json, and only prover knows this file. Also, this large number goes to output.json, and both the prover and the verifier has access to this file. Now let's go to our programming environment, Visual Studio Code, and start writing this Fibonacci series example in ZKP. First, create an empty file and save it as fibonacci.circom. Every ZKP code begins with the directive pragma circom and then the circom version, which in our case is 2.0.6. To start the execution, an initial component must be specified. By default, the name of this component is main. Only one main component can be defined. We write component main equal our circuit. The main component needs to be instantiated with a template. Templates are the mechanism for creating generic circuits in ZKP. They define circuits and they have their own signals. For example, we write template Fibonacci n. During the compile time, the function argument must be known. As in this example, we assign 1000 to n. The arithmetic circuits built using ZKP operate on signals. The signals are named with an identifier and declared using the keyword signal. Also can be defined as input or output. For instance, signal input fib1, signal input fib2, and signal output fibn. Signals may not define as input or output, like signal S1. In this case, they are considered intermediate. Also, you may want to create an array of input like this one. Signal output S2 n. Be careful to avoid using reserved keywords as your signal name. Here is the list of reserved words in ZKP that cannot be used as signal names. Apart from signals, ZKP also uses variables. Variables are identifiers that store non-signal data and are mutable. They are declared using the keyword var. Variables can contain either numerical values of the field or arithmetic expressions, particularly when used to build constraints. Variable assignments is achieved using the equal symbol, like variable a equal fib1, variable b equal fib2, or var c. Also, you can create an array of variables like var v1 and initialize your variable like this one. Once again, please ensure that you are not using a reserved keyword as a variable name. Then we continue with Fibonacci computation. Compute Fibonacci sequence. We write a 4 to calculate the last number in our Fibonacci series. 4 where I from 0 to n-1, I++, and these 3 lines. Your code is ready. To test your circuit, first save your circom program and then use the following command to compile your circom code. Go to the terminal and type circom fibonacci.circom -r1cs. If everything goes fine, you should see this message. Everything went okay. And circom provides a short summary for you. Then you can find the R1CS in the same folder. This one. Fibonacci.r1cs. Now we are going to quickly go over the types of expressions in circom. There are 4 types. Constant values, these are simply fixed numbers like 5 or 7. Linear expressions, which are the sum of variables and constants like 5 fib1 plus 7 fib2 plus 12. And then quadratic expressions, which are formed by multiplying 2 linear expressions and adding another linear expression. For example, 5 fib1 plus 7 fib2 plus 12 times 9 fib1 plus 4 fib2. These type of expressions are allowed in circom. The next one is not quadratic expressions. This category includes any expressions that do not fit into the previous one, like 5 fib1 7 fib2 plus 12, 9 fib1 4 fib2, then times fib1. This is not allowed in circom. As you see, this template multi-tree has v1, v2, v3 and one output signal called vn. Vn cannot be v1, v2 and v3. This is not allowed. So we have to follow this format. Let's go back to our programming environment and do a test. As you see in this code, we have 3 signals, v1, v2, v3. I save this code and then go to my terminal and type circom test2.circom output r1cs. As you see, circom compiler shows me this error. Non-quadratic constraints are not allowed. So I go back in my code and comment this line. I will save and try it again. Now it's working fine. Now let's discuss the signal assignment operation. So I go back to my Fibonacci code and do the assignment for my output signal. Assignment in Fibonacci can be done using this operation. Also, to create a constraint for our circuit, we can use fibn3 equals c. This instructs the circom compiler to generate a circuit that accepts only the signals where the value of fib1 is equal to that of c. The safer operation is this operation, fibn. This operation combines the first two to do an assignment and create a constraint. Therefore, I remove the first 2 lines and only keep the 3rd line. Then type times fib1, save it and go to the terminal to test it again. Circom fibonacci.circom -r1 cs.